Welcome students. In previous class we learned that what is dimension and how can we derive the dimensions for all types of physical quantities. Now today we are going to discussing about the types of physical quantities on the basics of dimension. That means on the basics of dimension how many types of physical quantities are there. So, on the basics of dimensions, all types of physical quantities are classified into four categories. One, that is dimensional variable. Two, that is dimensional constants. Three, dimensionless variables. And finally, dimensionless constants. Here we have to study all types with some examples. First of all, what is dimensional variables? That is a physical quantity which has dimension and its magnitude value is variable, then this physical quantity is called the dimensional variables. For example, area, volume, velocity, force, momentum, all are the example of dimensional variables. Now question is why and how area, velocity, force, momentum are called the dimensional variable. So to study it, at first we have to check its dimension, then we have to check its magnitude value. Suppose we have to find out dimension of area. We know that area means length into breadth, that is for length L and for breadth A also L. So the dimension of area, that is L square, and the dimensional formula is m to the power 0 L square t to the power 0. So area has dimension. Now question is, now we have to find its magnitude value of area. So suppose a rectangle of sides 5 meter and 2 meter, then what will be its area? Area will be 5 into 2, that is 10 meter square. Here its magnitude value is 10. But if I say a rectangle sides of 5 meter and 3 meter, then its area will be 5 into 3, that is 15 meter square. Magnitude value here 15. So here magnitude value is varies with respect to previous one. That's why we can say that area is an example of dimensional variables. And also we know that for different configuration, for different substance, for different figure, the area magnitude value is different. Similarly, for velocity, formula is displacement by time. Now for displacement, dimension is L, and for time dimension is T. So the final dimension, that is m to the power 0 L t to the power minus 1. Here that velocity has dimension and its magnitude value is also variables. Suppose I can say a body moving with velocity 10 meter per second square. Sometimes I can say a body moving with velocity 15 meter per second square. So its magnitude value is changes, but it has fixed dimension, that is m to the power 0 L to the power minus 1. So velocity is an example of dimensional variables. Similarly, force. The force has a dimension, that is m L t to the power minus 2, and its magnitude value also changes. Suppose I can apply a force of 20 Newton on a body. I can apply a force of 15 Newton on a body. I can apply a 10 Newton force on a body. So its magnitude value is changes for taking different examples. So velocity, acceleration, momentum, all are the example of dimensional variables. Next, that is point 2, what is dimensional constant? What is dimensional constant? That is the physical quantities which has dimension but its magnitude value is constant, then these types of physical quantity are in the class of dimensional constant. For example, gravitational constant, Planck constant, permittivity of free space, etc. Suppose we have to find out the dimension of capital G, that is gravitational constant. So at first we have to find out the formula from where we can derive it, and the formula is gravitational force that is F equal to G m1 m2 by r square. Then from this equation the value of G will be F r square by m1 m2. So just putting the individual dimensions, then the final form of G will be m to the power minus 1 LQ t to the power minus 2. So it has a dimension and the dimension is m to the power minus 1 LQ t to the power minus 2. Now the magnitude value of G, that is fixed value. The value of G in CJ system is 6.67 into 10 to the power minus 8 dyne centimeter square per gram square. And for SI system, the value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So it has magnitude, that is fixed value, it has dimension. So we can say that gravitational constant is an example of dimensional constant. Similarly, from equation E equal to h nu, we find out the dimension of Planck constant, and the value of Planck constant is approx 6.63 into 10 to the power minus 34 joule seconds. So G, Planck constant, permittivity of free space, all are the example of dimensional constant. Dimensionless variables. So what is dimensionless variables? The physical quantities which has no dimension and the magnitude value is variable, then these types of physical quantities are in the class of dimensionless variables. For example, angle, relative density, strain, all are the example of dimensionless variables. Now question is why? Suppose angle. Angle means arc by radius. Now arc means length, that's dimension L, and radius mean length, dimension is also L. So L by L, so dimension is L to the power 0, and there is no function of m and t, so the power of m and t will also be 0. Then the dimension of angle will be m to the power 0, L to the power 0, t to the power 0. So it is dimensionless. Suppose sin theta. Sin theta means perpendicular by hypotenuse. Perpendicular, hypotenuse, both are means length, that is L by L. So function is m to the power 0, L to the power 0, t to the power 0, dimensionless. But its magnitude value changes. Sometimes angle made 30 degree, 60 degree, 40 degree, etc. So angle are the example of dimensionless variables. Similarly, strain. Strain is an also example of dimensionless variable. Why? So at first we have to know what is strain. Strain means the ratio of change in configuration to the original configuration of a body is called strain. So if we consider length, then its formula will be change in length by original length. If we consider area, then formula will be change in area by original area, and considering volume, formula will be change in volume by original volume. Suppose I consider the length of a substance is 5 meter. Now by applying force, the length of the substance changes and its final length, that is 8 meter. So what is the change in length? Change in length means 8 minus 5. So change in length 3 meter by original length, that is 5 meter. So 3 meter by 5 meter, both are the ratio of length. So upper portion L, lower portion L, that is the dimension is m to the power 0, L to the power 0, t to the power 0. Similarly, if we consider area, then its form will be L square by L square, that is also m to the power 0, L to the power 0, t to the power 0. And for volume, LQ by LQ, that is also same. So here strain is an example of dimensionless variables. So strain, relative density, then angle, all the example of dimensionless variables. And then the final form next, that is dimensionless constant. Dimensionless constant means the physical quantities which has no dimension but its magnitude value is constant. That is, suppose pi is a dimensionless constant because it has no dimension and its magnitude value is 22/7. The value of E is around 2.71828 and it has no dimension. So pi E, similarly any natural number, all are the example of dimensionless constant. So in this class we learned that on the basics of dimension, the physical quantities are classified in 4 categories. 2, that is dimensionless constant, dimensionless variable. Another 2, that is dimensional constant, dimensional variable. Clear? So this is all about today class, and in next class we will discuss an important part, that is the importance of dimension analysis and how to and where we can apply the dimensional constant. What is the advantage of dimension analysis? Okay, so stay tuned and thank you.